Well, when we're flying a plane, the aeroplane doesn't really know what height it is, but the aeroplane does fly according to how many air particles there are in its environment. Now, the closer you get to the ground, the more air particles. And so the thing is, when there's more air particles, the aircraft flying through more air particles is going to have better performance because the lift on the wings is going to be a lot easier for the airplane than up higher. When you get up higher, the air particles are not so close together, so you have less dense air particles, and therefore the aircraft has to actually fly much faster to have the same sort of lift. So the lift depends on how many air particles are flying over the wing. So what we're going to be looking at in this session is a term called density altitude. Now, a plane will fly in a similar manner at a particular density altitude. Now, if you have a plane flying through this many air particles, it doesn't matter where it is in the world, if that's the density altitude of whatever the density altitude of that aircraft is, it'll have the same performance. Now, the last session I talked about pressure height. Now, pressure height and temperature have to be worked out, combined, and combined to work out density altitude. Now, we spoke about 15 degrees Celsius at mean sea level at a particular pressure, and that was the pressure height of 0 feet. Now, if we go up, say, 7,000 feet, remember last session said, well, that's 7 lots of thousands, and each thousand, the temperature drops by 2 degrees. So the temperature is going to drop by 14 degrees Celsius. So at 7,000 feet, we're going to have a temperature of 1 degree Celsius. Now the thing is, as the sun heats up the ground and you get a higher temperature on the ground, you get heat waves coming off the ground. Heat waves are going to cause the air particles to warm up. And so what will happen on a very hot day? Let's say we're up here at 7,000 feet and the temperature actually is not 1 degree Celsius. Remember, that's a model of a pressure height. Let's say the temperature is really, let's say it's 10 degrees. Let's just say 10 degrees Celsius instead of 1 degree Celsius. Not 1 degree Celsius, it's 10. Well, that's 9 degrees warmer. Now the thing is, every degree will cause our air particles to disperse. Every time the temperature gets hotter, these air particles disperse to a point where the aircraft feels as if it's actually in a higher position, just because the air particles are warming up. So the level might stay the same, but the density altitude might be increasing. So at this 7,000, every 1 degree will be an increase of 120 feet. That's going to add on to the density altitude. So that is 9 degrees warmer than 1 degree. So if it's 9 degrees warmer will increase the density altitude by 9 times 120. Quick calculation, 1,080 feet will be added on to 7,000. So for all intents and purposes, a pilot flying at 7,000 feet will not be saying 7,000 feet altitude. This is a density altitude of 8,080 feet. Now that is going to be used to work out the performance of the aircraft. Now the aircraft is performing as if it was at 8,080 feet, not at 7,000. That's simply because the temperature is increasing, and for every degree Celsius, up 1 degree Celsius will increase by 120 feet will be added on, and that is known as the density altitude. So remember, the aircraft performs different as the air density becomes less. The aircraft has to go faster to take off. If it's a hot day, the aircraft has to take faster speed before it will get the lift. So it's often better flying early in the morning or late in the afternoon. But just keep in mind, if the temperature's hot, just do a calculation of the density altitude and you will then have an idea on how the aircraft will perform. It's performing as if at 7,000, it's actually performing as if it's at 8,080 feet, if the temperature is 9 degrees warmer. Okay, so I've introduced the term density altitude. We'll do some more practice of this in future sessions, but until I speak to you again, stay happy.